Hello everyone. We are starting a free open lecture on our Discord. All our lectures are held weekly without breaks. If you, the viewer, want to ask questions and get answers in an online format, join our lectures. You can find the link to our Discord in our Telegram channel. To easily find out the lecture times, join our Telegram channel, prefix sum, a simpler and shorter version. Well, the logic will be exactly the same there. As the prefix sum is built, we take our string ABC. Here we have A1, then here we will have A2, then here we will have A2 and also B1, and here we will have A2, B1, and C also as 1. This is the prefix sum. So for example, to check if, let's take this substring. The prefix sum is a cumulative sum of the elements in the string, which helps in quickly calculating the sum of any subarray. For instance, if we want to find the sum of elements from the second to the fourth position, we can simply subtract the prefix sum at the first position from the prefix sum at the fourth position. This method is efficient and saves time compared to recalculating the sum for each query. Additionally, the prefix sum can be used in various applications such as range queries, dynamic programming, and more. This is A, this is B, this is C. If I want to check on this substring, for example, whether I can construct a palindrome or not, then I just need to take this map. And you kind of need to subtract this map from it. And overall, yes, you can do the same thing with the prefix sum, but I immediately use the segment tree because there will probably be some updates to make. Updates don't work in the prefix sum. So, how do we quickly build our palindrome now? Well, first of all, we need to remember that there is such a thing as a lazy segment tree, and on a lazy segment tree, we can perform the operation of assigning an element to the entire segment. That is, we can set some x on the entire segment, and essentially, this is what constructing a palindrome is. Why? Because if we have some, let's say we want to put some palindrome on a substring AA, we need to consider how palindromes work. A palindrome is a sequence of characters that reads the same backward as forward. For instance, race car and level are palindromes. Now, let's put it in context. Imagine we have a string and we want to insert a palindrome within it. We could take a substring like AA and place it in the middle of our string. To make it more interesting, let's add the letter D in the middle of this palindrome. So our string might look something like ADA. This way, we have a palindrome with D in the center. This example helps us understand how palindromes can be integrated into substrings and how they maintain their properties even when additional characters are included. Assignment: in a lazy segment tree, this operation is performed by the attend algorithm as well. Let's think about how long such a thing can take. In the worst case, if we are assigning, well, we have this here, and kind of each one. This is the segment. In this particular segment, it will be established in a manner that is logarithmic, which is a mathematical term, time, and we will perform this operation twice because we need to set it first and then set it again at the end. Therefore, we immediately multiply by 2 again and then continue. How many such segments can we have at most? We have a finite alphabet. Our alphabet goes from A to Z, and that is 26. Accordingly, we can have a maximum of 26 such segments. Well, here is an additional +1, sort of. So let's add this one. Another logarithm. So, in the worst case, we multiply by 26 again. We multiply the letter by 26, and we will just go through the set that we have obtained.
Want to become a great programmer? Subscribe to our Telegram channel.
We can assign to a segment with this complexity 52 to the logarithm base 2 of n, which is generally considered to be quite acceptable. Typically, well, this 2, it goes through here, with us 26. And what final complexity will we get? Let me denote 26 as C, which is an unchanging constant value. This is a constant value. And then I will have m queries in total. So each request will require me to do something. First, I need to get all letters in the substring. I will do it for the price of the logarithm of 10, the price of the logarithm of 10, and then I need to go through these letters. That is, it's basically a conditional count with verification, essentially. What I can make out of them is a palindrome. And what else will I need to do? I will need to do this. To do this, that is, to set the value, in the worst case, it will be, we calculated, Well, 52, something like 2c times the logarithm of n, and in the end, we get the complexity, something like m times c. And here are some 2 logarithms, basically mc logarithm of n. That's our final solution complexity. Well, that's basically it. Next, it just needs to be coded, because we already have everything here. The structure of the element in the tree is basically written. It could be a set, but then I simply switched from a set to just an array of 26 elements. We are expanding, not a set, because dealing with it would have been cumbersome. But with an array, you can quickly go through and sum up. And what else? Well, a function for summing arrays. We simply take the indices in pairs, add the values at the indices in pairs. This is a function on the tree. Next, I have lazy, which means that I had this value already stored. The addition is done through the plus operator, which shows how to add 2 vectors together. The lazy value, which I found to be simply lazy for me, was just an integer. Why? Well, because that means I assign to a specific segment. Let's say some A, right? You see, this means that I need to set this kind of vector over the entire segment, where I have a 1 here and zeros everywhere else. Well, accordingly, this is A for me, and this is Z. Therefore, I don't necessarily have to take the whole vector. I can just take an int. So, lazy compose is when I need to first implement one lazy operation and then apply another one to exactly the same place. Essentially, this function takes 2 lazy values. Essentially, lazy1 and lazy2. Essentially, it will always return L2. Because I have an assignment, it is like the very last assignment, and this is what I had and what needs to be applied. It will replace the first one in any case. Therefore, lazy compose is like this, and I also need the lazy apply function. This is a function that applies lazy to my value. What does it do? Well, here we need a topic like lazy. I will write about it. This topic is very needed as with plus and plus, so I also need to pass the function, the segment for which the node is responsible, to which I apply the lazy value. So, my condition here will be, if L corresponds exactly with R, then I am at the very lowest node, that is, in the leaf. And there I just need to set the value through return. I need to set this very important lazy value. In this scenario, I will have an array named C. Within this array, there will be a specific position referred to as the lazy position, where I will place a value of 1. In all other positions within the array, the values will be different. Now, considering this setup, what do I need to return? Return the same array C, but at the lazy position, in the array, specifically at the specified position, instead of the number 1, it will now have the value of RL plus 1. But it's like with addition, that is what should be executed for me. So if we take what works well is that a plus b multiplied by c should essentially be transformed into a times, c plus b times c. This is the distributive property of multiplication over addition, which is a fundamental concept in mathematics and is used to simplify expressions. I can expand the brackets, and this is how it should be done. So what exactly do I need to do? I need to calculate the sum of a and b. Let me put an assignment here, which will be assigned to the variable c for further use. This expands for me, meaning it should, in a way, again expand as a is essentially assigned plus b, and therefore also assign c to the variable, and we are guided by this particular thing because it is kind of correct in a way. The right part is what we should ultimately and essentially end up with. And here we have c and here we have c, and as a result we get 2c. But if we expand this, the parentheses are executed first. Here we have some a plus b value, and then we replace this value with the variable c. Here we simply and straightforwardly have C. Therefore, here we need to make a modification where we also need to consider the segment, and it will turn out to be a plus B in this case. We assign not C, but C multiplied by delta L, where delta L is the number of elements in the segment. This way, everything will expand correctly because here I have 2 elements, and here I assign 2C, so I get 2C. Or I can explain it more simply with addition. Suppose I want to add some C to the entire segment. I should basically end up with ultimately adding C to element A, right? And then essentially adding C to element B. What does that actually equal? A plus B and plus 2C? If I expand this, I get a plus B and plus C. Well, it's not enough, right? So what do? I take and do a plus B and add not just C, but C multiplied by the same delta L, as many elements as there are in the segment. Here, it's essentially the same analogy. Well, that's it. So, LazyPly is ready.
Want to become a great programmer? Subscribe to our Telegram channel.